Hey everyone! This is Gayatri from Youthbuddy. Dear programming students, aspiring software developers, and coding enthusiasts tuning in. If you are someone who wants to build strong programming skills and create high-performance applications, this is especially for you. Many learners start studying C++ but often feel unsure about what to learn first and how to progress toward advanced topics. Here's something helpful for you: a deep study roadmap for C++ programming language from Youthbuddy. To explore this, visit the Youthbuddy website, go to the Education section, open Study Roadmap under the IT and CA's Courses Learning category, and select C++ on that page. C++ is one of the most powerful programming languages in the world, and it continues to play an important role in software development, game engines, operating systems, embedded systems, and performance-focused applications. A strong learning journey begins with the fundamentals, including program structure, input and output operations, variables, data types, operators, conditions, and loops. Once the basics are comfortable, learners can move into core programming concepts. Functions, recursion, arrays, strings, pointers, references, and memory management help build a deeper understanding of how programs work internally. One of the most important milestones in C++ is object-oriented programming, covering classes, objects, constructors, inheritance, polymorphism, encapsulation, and abstraction. Templates, exception handling, namespaces, inline functions, and file handling introduce more flexibility and efficiency into application development. Modern C++ introduces smart pointers, lambda expressions, move semantics, multithreading, and the standard template library, helping developers write cleaner and more efficient code. The STL includes containers such as vectors, maps, sets, and lists, along with algorithms and iterators that improve productivity and problem-solving. Modern language features from C++11, C++14, C++17, C++20, and newer standards include auto, range-based loops, structured bindings, concepts, ranges, and coroutines. System-level topics include memory optimization, low-level programming, bitwise operations, and performance-focused coding techniques. These areas help developers understand how software interacts with hardware and how efficient applications are built. Building calculators, text-based games, networking applications, GUI programs, and data structure projects helps transform knowledge into practical skills. Git, CMake, debugging tools, testing frameworks, and profiling tools help prepare students for professional software development environments. As skills continue to grow, learners can challenge themselves through competitive programming, open-source contributions, design patterns, library development, and advanced software engineering practices. What makes C++ unique is its combination of speed, flexibility, and control, allowing developers to work close to the hardware while using modern programming techniques. By following a structured roadmap and consistently practicing through projects, learners can steadily progress from beginner concepts to advanced development skills. Whether your goal is software engineering, game development, system programming, embedded development, or high-performance computing, C++ provides a strong foundation for long-term technical growth. Stay tuned for more useful info. For more details, click the link in description or explore it directly in the Education section on the Youthbuddy website. Open Study Roadmap under the IT and CA's Courses Learning category and select C++ on that page. Like, share, subscribe, and follow our social media accounts for more updates. Yours Gayatri from Youthbuddy, signing off.